Problem B5. A regular octagon ABCDEFGH has side lengths of 1. The lines AC and HF meet the line going through D and E and P and Q respectively. What is the length of the line PQ? Now, to approach this problem, there are several ways of doing it. However, I'm going to leave a practice for you guys, okay? So I'm going to show you a very long way that I used in a competition, but it's not the best, but it's actually pretty fun and it's very satisfying at the end if you actually know. It's going to be very satisfying my way, but I want to leave you a practice, guys. Try and find a shorter way because there are shorter ways. Let's get started. So I'm going to first construct some lines from A to D and also from H to E. I'm also going to construct lines from, let's see, B to G, and from B to G, also from C to F. Now, these are the lines I'm going to construct. I'm also going to drop this line down over here, and it's perpendicular. And now I'm going to use my little tool. Actually, no, yeah. Okay, so I'm going to label this point X and this point Y. And now I'm going to find the length of this blue line over here. So let's see. This length here is 1 because it's just a side length. Right over here, 1. And this length here is equal to this length here because this octagon is regular. So I can just write, let's just label this X. The length is X. X squared plus X squared is equal to 1 squared. This is just the Pythagoras theorem. And now I have 2x squared is equal to 1 squared. And then I have x squared is equal to, well, that's just 1, right? So I get 0.5. This is equal to 1. Now, 0.5, we just take the square root. No negatives here because we're dealing with distance. Square root of 0.5. We get x is square root of 0.5, and I'm going to erase this. So now I'm just going to take a note of that up here because we're going to be using that later. X is equal to square root of 0.5. Okay. Now we also find that this is blue and this is blue because they're literally the same lines. They just dropped down and slid across. So triangle EYF is congruent to triangle EXF. Now what we can also notice here is that we can also notice that, I'm sorry, but I'm having trouble with changing my color. We can also notice that this triangle over here, HYF, is similar to triangle FXO. Why? Due to angle similarity. This angle is a right angle. This angle is also a right angle. This angle is equal to this angle because these two lines are parallel and they are corresponding angles. Now, AA similarity postulate says that these two triangles are similar. You might be asking, how about the third angle? But the third angle is just 180 minus these two angles. So it's always going to be the same for these two triangles. Now, we're going to use this fact, and we're also going to use this fact to our benefit. This length over here is also x, right? And this tall length over here, this is x as well, because this is just this but moved, okay? Because this octagon once again is regular. So this is x and this is 1 because it's one side of the octagon, so that's 1. So the whole side length of this is 1 plus x. That's amazing. Okay, now we're not going to be working out this edge. Don't worry, we're not going to be doing that much algebra. But we're going to be observing this one. this length is x, the one I'm shading in green here, right? And this bottom floor length we don't know. And that we want to know, because then we can add to this length, which we already know, and then it's the same for this side, and then we know 1 is here, so then we know the whole length of PQ. Amazing. But how do we know this mystery length over here? Proportions. Yes, I've done many videos on proportions. Well, using proportions. So we can set up the proportion over here. Since they're similar, we have proportions. So hy, which is 1 plus x, over the corresponding side, which is fx, which is the square root of 0.5, is, okay, let me just correct this a second. The x is just square root of 0.5 over here. So that, let me just rewrite this. So 1 plus the square root of 0.5 over the square root of 0.5, right, is equal to this bottom side, which is the square root of 0.5, over x. Well, not x. Let me just label that side y. So I'm gonna call this mystery length over here, I'm gonna call it y. And we return to our equation here. Now we can do some cross multiplying and simplification to get 1 plus the square root of 0.5 multiplied by y is equal to the square root of 0.5 times the square root of 0.5. This simplifies to y plus the square root of 0.5y is equal to 0.5. Yeah. And now we just have to solve for y by isolating it. So if we just, well, actually, we can just solve for y in terms. But what I'm gonna do here is a bit different from what we usually would think. Because, wait, I'm just going to quickly simplify back, because I have just made a mistake. But mistakes are fine, we're gonna correct it, it's fine. Okay, 1 plus the square root of 0.5 times y. Now we're gonna divide by 1 plus the square root of 0.5. Yeah, that's much easier. So y is equal to 0.5 over 1 plus the square root of 0.5. Grand ending. Okay, now we know y. We just have to add it to this thing, then multiply it by 2, then add 1. Then we know the answer. So let's move it here. So we know this length over here is just x from before. So it's the square root of 0.5 plus y, which is, I'm just literally going to show you this. So y is equal to this. So I'm going to erase this and I'm going to plug this in. And that is equal to, well, what is it equal to? Now this is the grand celebratory finale of the entire calculation, the messy algebra, the square roots. Let's do it. Convert into common denominators. So if you multiply by 1 plus the square root of 0.5 for this one, so it's going to be square root of 0.5 times 1 plus the square root of 0.5 over 1 plus the square root of 0.5. That is that. And then plus 0.5 over 1 plus the square root of 0.5. Some quick algebra people might be noticing where this is going. Simplifying this, we get square root of 0.5 plus square root of 0.5 times square root of 0.5 is just 0.5, okay? You get that? Okay. And then over 1 plus the square root of 0.5. And ready? Plus 0.5 over 1 plus the square root of 0.5. And this is equal to 0.5 plus 0.5 is 1 plus the square root of 0.5 over 1 plus the square root of 0.5. And this is equal to 1. The length is 1. Woohoo! we know the length is 1. We multiply it by 2 from before, because this bit and this bit, I know my drawing's very messy, sorry, plus this middle one, and you get 3. And that is our answer from all of that. So the answer to this question, the length of PQ is 3 centimeters, and that is our answer. Now, a note on the easier methods. There is a much easier method. It is using the angle facts. I'm going to erase all of this to work out that this length. So it's not necessary to draw the lines. I did, but they worked out that this is an isosceles triangle. These two angles are same. They worked it out. You might have some ideas already, but I'm not going to say much. It's an exercise for you to work it out. And then they knew this was 1. They knew this green length was 1, so they also knew this one. And then they did the whole thing. It's much easier to do. Trust. But this is just a very satisfying way of solving it. It's the way I used it during the when I was looking for the questions. So yeah, and thank you guys. This is a very long way, and bye.